This is worksheet 27.3, and we're going to look at number 1, revisiting the baby weight question that we saw on worksheet 27.1. So using that same data, I'm just going to write down the mean we had. Mean baby weight was 7.6, standard deviation was 1.3. So in this question, Mrs. Saucerpasser has just given birth to her infant son. Due to the chaos in the delivery room, she does not remember the details of her son's birth, only that the doctor remarked that he was a very heavy baby in the 80th percentile of all American babies. So that statement means that 80% of babies weighed less than this baby. Make a hypothesis using the empirical rule. Approximately how many pounds do you think the baby weighs? So using the empirical rule, we can just sketch the normal model. So since we're at the 80th percentile, we know that this baby is at the 80th percentile, which if you look at the percentages, we know this half is 50%. This, from the mean to the first standard deviation, is another 34%. So this mark would be 84th percentile. So this baby is a little bit less than that. So I'm just going to draw a line a little bit less. We know the average baby is 7.6. One standard deviation above would be 8.9 pounds. So this baby, if we were to just take a guess, since 80% of the babies weigh less, we could say a little bit less than 8.9. Just taking a guess, you could approximate it. So this will vary depending on what you think. So I'm just going to put approximately 8.8 pounds. Now, in part B, we're actually going to use the z-table to determine exactly how many standard deviations a baby weighing in the 80th percentile would be. How do you know which table to use? If the baby is above average, so here you can see that the baby is weighing above average, the z-score is going to be positive. So we want to look at the positive z-score table, which is this one, as opposed to this one that has negative z-scores. And we're working backwards. We know that it should be in the 80th percent, so 0.8. And you just want to find the value that's as close to this as possible. So in the z-table, where you have positive z-values, we're going to look for the number closest to 0.8. So here you get close to 0.8. I'm going to choose the one that gets as close as possible but without going over, so 0.7995. And then working backwards for the z-score, you get 0.8. And then up here on the top, you get the hundredths place. So where was that? 0.7995, so 0.84 is the z-score. Alright, so now that we know the z-score, we're going to use the z-score from part B and the z-score equation to solve for the weight of the baby. So in my z-score equation, I know that z equals the weight of the baby minus the average weight divided by the standard deviation. So 0.84 equals x minus 7.6 divided by 1.3. So if we solve for x, we have to multiply by 1.3 and then add 7.6 to that answer. So we get x equals 8.7 pounds, which is more exact than our guess up here, whatever you ended up guessing for the weight of the baby.